Once again, good morning to one and all. Myself, Arun Kumar K, Assistant Professor, Aeronautical Department at MLR Institute of Technology, Hyderabad. So, in today's lecture, we are going to discuss about limitations of first law of thermodynamics, and we are going to enter into second law of thermodynamics. So, this is your unit number 2. So, in the previous lecture, we have done with the unit number 1, so up to steady flow energy equation, right? So before entering into second law of thermodynamics, so everyone we supposed to know what are the limitations actually we have faced with respect to the first law of thermodynamics. If I know the limitations of first law of thermodynamics, then we can able to overcome that, so we can able to enter into second law of thermodynamics. Right? So straight away we'll enter into the today's lecture. So I'm just recalling what's the first law of thermodynamics states and what's the purpose of first law of thermodynamics, as already we discussed in the unit number 1 also. So with that actually we can able to discuss the limitations. See, everyone knows that first law of thermodynamics states that, right, energy can never be destroyed nor and can be formed, right, and it can just transform from one form to another form. So we can't able to destroy it and we can't able to form it. But the thing is that only it can able to transform from one form to another form. Right? So this is what the simple statement of first law of thermodynamics. Or in other word, we can able to say that is nothing but law of conservation of energy as well as the mass. Right? So this is what actually the first law of thermodynamics states. Now, with this statement, what are the limitations actually we are facing? See, only it talks about the transformation from one form to another form. Right? Only the form actually it can able to describe. But what about the quantity and how much it can able to transfer? That we don't know with respect to the first law of thermodynamics. Right? See, simply I'll consider with respect to the closed system which we discussed in the unit number 1. That is what Q equal to W plus del V. What it states actually, whatever the energy I have supplied, assume that again the heat energy is transferred to the system. That is what actually the desirable or positive sign we consider. Right? So whatever the heat energy we have supplied, that is converted into other form of energy. What is that? Mechanical work done, right? Plus it is stored as the internal energy, change in internal energy. Right? So how much energy actually heat energy converted into with respect to how much mechanical work done, and still how much internal energy we are having as a final state, that we don't know. Right? So like this, if I point out the limitations, then I can able to get into new law of thermodynamics. That is what actually second law of thermodynamics, for the various statement we are having. Right? See, this is what actually the statement given, right? Only the energy before and the energy after it transforms. That's it. We don't have any value over there. We don't have any quantity over there. Right? So this is what the simple first law of thermodynamics statement. So with this actually I can't able to apply with respect to the actual cases. For example, actual heat engine. Right? So I can't be able to apply this first law of thermodynamics. I can't able to sense with respect to the quantity, and I can't able to evaluate the performance parameters. Why? Because everything is converted into other form of energy. Right? So if that is the case, how to evaluate the performance? So with first law of thermodynamics, we can't evaluate it. Or simply we can able to say, with respect to the first law of thermodynamics, the performance parameter like efficiency or other performance parameters, right, will be having a certain percentage. So that is what actually we are having serious limitations of first law of thermodynamics for the actual cases. See, if it is ideal cases, no need to bother about it. But with respect to the actual cases, I can't able to evaluate all the performance parameters with the first law of thermodynamics. Right? So that is what the series limitations, or we can say the disadvantages we are having. So with that mathematical expression I have given earlier, see, this is what internal energy E2 minus E1 is nothing but change in internal energy, right, which is equal to nothing but heat energy minus mechanical work done, right. See here, this is the movable boundary we are having. Because of that we are getting the mechanical displacement also, or the simple term Q equal to, I can able to say W plus del U also, del U or del U, whatever it may be, right, with respect to state 1 and state 2. So this is the process actually we are having. Got it? So in this way, actually, we are having only with respect to the first of thermodynamics. This is the statement we are having for the closed system, right? So for a easy understanding purpose, I will take the closed system, right? See, then what are the limitations actually we are having with respect to the first law of thermodynamics, and why so? See, our first limitation is nothing but the first law doesn't help to predict whether the certain process is possible or not. Right? See, when this is required actually, whether the process with respect to the particular machinery, right, with respect to the particular heat engine, we'll consider whether that process is possible or not. Right? Why? Because it is applicable only with respect to the energy transformation. It doesn't mention any quantity over there, so I can't able to evaluate the performance parameter, so that I can't able to sense whether it is possible or not. So with the first law of thermodynamics, that is my first limitations we are having, right? See, with respect to the reasons why, what are the reasons we are having actually? See, it does not specify the heat can't flow from low temperature body to high temperature body, right? See, but in the actual cases also it is possible. But with respect to this first law of thermodynamics, I can't able to, does not specify, right? I can't able to sense the heat can't flow from low temperature body to high temperature body. It doesn't mention with respect to whether the heat is transferring from source to sink or sink to source, right? So that reservoirs will discuss later. That is what source is nothing but actually we are having high temperature body, and sink is nothing but we are having the low temperature body, right? So it doesn't specify that particular thing. So that is why this limitations actually we are considering as a first law of thermodynamics limitation, right? And see, the next one is nothing but the first law doesn't give information about any direction, right? Only the transformation takes place. The transformation takes place from systems to surrounding, or surrounding the system, or from one body to another body, or between the two systems, right? So it doesn't mention the direction of the heat flow or direction of the work done, right? So it doesn't mention any the direction with respect to the first of thermodynamics, right? See, for example, it puts no restriction on the direction of heat flow. So we'll consider the heat energy. Why? Because we are supplying the heat energy to the system, right? So whether the heat can flow from a cold body to a hot body or vice versa, right? So with the first law of thermodynamics, actually we can't able to predict whether the heat flow happens from lower body to higher body or higher body to lower body. So with that simple statement, we can't able to sense it, right? So this is also actually we are facing the serious limitations of first law of thermodynamics. So this actually we can able to overcome with the next law of thermodynamics, that is what second law of thermodynamics, with the various statements, right? So this is what actually the next limitation. See, that is what direction, about the direction. The first one is nothing but feasibility, whether it is the particular process is possible or not, right? So next one is nothing but about the direction, right? So with that simple statement, we can't able to evaluate it. And see, so this is what the picturization we are having for this second limitation, right? Why does energy travel always from higher value to lower value? Higher body temperature body to lower temperature body, right? So always the heat transfer from hotter side to the colder side. This one actually they didn't mention with respect to the first law of thermodynamics, right? Only the transformation takes place. In which way it takes place? It doesn't mention the direction, right? So the next third limitation is nothing but see, it does not provide any specific sufficient conditions, right, for the certain process to take place. So how much it takes place, got it? So in which way it takes place? It doesn't provide any data, sufficient conditions, right? So the conditions actually we supposed to specify for the actual cases. But with respect to the first law of thermodynamics, we are not having any sufficient conditions for that particular process, right? See, the reason is nothing but, so see, that is what the evaluation parameter actually we said. So this is the combination of all limitations we can come up with respect to the third limitations. So altogether we can put with respect to this third limitation. See, listen here, this law is silent about. So silent in the sense it doesn't mention anything about its percentage. What is that percentage is nothing but actually evaluation performance parameter. Evaluation of performance parameter. Simply we can able to say with respect to the efficiency, right? So the percentage of conversion of energy from one form to another form, right? Percentage of conversion. So how much quantity it is converted, that actually we don't know from one form to another form, right? So heat can't be converted into equivalent amount of work. So that is what actually in the actual cases. This is applicable for the actual case that everyone knows, right? Heat energy can't be converted into equivalent amount of work for your automobile engine, right? Heat engine. For that actually the heat energy which is generated with respect to the particular air-fuel mixture, and that amount of heat energy, right, it is not converted with respect to the same amount as a mechanical work done. So we are facing more losses, and because of sink or surrounding, right, some heat is rejected to the surroundings. So because of this actually we can't able to evaluate the percentage, right? Evaluate the percentage, or we can say the efficiency. Simply we can say the performance parameters. So this is what actually we are having the series of disadvantages. Right? Say for example, if I want to calculate the neta, right? So neta is nothing but we are having always output by input, right? So for the particular machinery, right, it works with respect to hot body to cold body. That is what the spontaneous one. So always the spontaneous process is nothing but from hotter body to cold body, the transfer takes place spontaneously, right? So in that way, I'll consider like heat engine, the efficiency is nothing but actually the output, right? Output by input. So what's the output actually? We are getting the mechanical work done as the output, or mechanical displacement work done as the output. So what is it actually we are having? W by, that is what mechanical work done by heat supplied, that is your input, right? So heat is nothing but capital Q. So heat supplied, QS, right? So how much it is converted actually? We don't know, right? We don't know about this, how much it is converted. Assume that all the internal energy is for the cyclic process, right? What happened actually? It is converted into form of work done, right? See, for the cyclic process, everyone knows that summation of Q equal to summation of W for the cyclic integral or cyclic process we are having, right? So if I apply this one, actually what will happen? This work done by heat supplied is nothing but actually we have converted every heat supplied with respect to the mechanical work done. So we'll get in terms of neta equal to 1, right? So that is what this series limitations actually we are having with respect to this various limitations with respect to the first law of thermodynamics, right? So I can't able to evaluate the parameter and doesn't mention the direction. And with respect to this, I can't able to find out the feasibility of the particular process, right? So these are the series limitations we are having. See, then if I overcome these limitations, right? If I overcome these kind of limitations with respect to the various statements, that is what the second law of thermodynamics, in that actually we are having with respect to heat engine, That is what from hot body to cold body, we are having Kelvin Planck statement, right? And after that, actually, we are having from cold body to hot body also, we can able to transfer that is also possible until if you supply work input to the system. So for that, actually, we are having the class A statement. So with respect to this, actually, I can able to overcome all these limitations. That leads to the second law of thermodynamics. So for the second law of thermodynamics, actually, I supposed to read the statement according to hot body to cold body and cold body to hot body. So with that, I supposed to frame the statement so that I can able to overcome the limitations of first law of thermodynamics, right? So that is what these are the various limitations actually we are having. Say for example, see listen here. Here with respect to that heat engine, I'll consider from the mechanical work done. See, this is what the mechanical work done we are having. It won't says, right? So from fuel supply to this one, actually I can able to convert that into form of mechanical work done. From the mechanical work done, I can't able to extract the fuel, right? Over here, I can't able to convert it, right? So that is what the non-spontaneous. That is what actually we can't able to do that. So these are the things actually we are not having with respect to the first law of thermodynamics. But if I discuss the first second law of thermodynamics, what happened? I can able to sense all these parameters, whether feasibility, whether the directions, or whether the performance parameter evaluations, right? So this is what the overview of first law of limitations of first law of thermodynamics, right? So thank you everyone. So in the next lecture, we'll discuss about the second law of thermodynamics. So thank you all.